Right, we had to draw these ray diagrams, and let's now consolidate and see what we've done. If it was between the focal point and the lens, we'd already done beyond 2f, so that's been done over and over. Now we've got our principal axis. Don't forget to draw your convex lens. Your object is between f and the lens. I draw a ray parallel, a ray through f, a ray through m. They're never going to meet, obviously, so I dot them back. That results in an upright from the principal axis to those rays is an upright virtual image that is bigger than the object on the same side of the lens. If my object is at f, I draw, I go through, and I find that these two rays are parallel. So going forwards or backwards, they will never meet, and I have no image being formed. If my object is beyond 2f, we've done this one a million times over, as I said. Here's my object at 2f, and it turns out that I get a perfect little image exactly at 2f on the other side of the lens. It's real, it's inverted, and it is the same size as the object. So ray from the top of the object to the lens, diverts through the f, through m, until they meet again. Don't forget your arrows on your diagram. Here we're between f and 2f. I go parallel ray through f, ray through m until it crosses. I get an enlarged, inverted, real image beyond 2f on the other side of the lens. What about if I now have a diverging lens? Again, you're going to draw one ray that is parallel to the principal axis, except you're going to diffract it in such a way that it appears to come from the focal point. And I'm going to show you one of those now. You're going to draw both of these in a second. Draw one ray to pass straight through the center of the lens. So let's go through one. So my object is between f and the lens. I draw a ray parallel to the principal axis. I diverge it so that it thinks it came from f. I also take another ray down and through m. Where those two rays cross, I get an image. I've got a dotted line involved, and therefore I am going to have an image that is virtual, it is upright, and it is diminished on the same side of the lens. You can try the next one, where I've put the object between f and 2f on the other side of the lens. Object goes along, at least the ray goes along, diverges as if it came from f, and I have again put the next ray through m, and I've got an image that is diminished, upright, and virtual. These properties are always true of a diverging lens. No matter where I put the object, my image will always land up between f and m. On the same side of the lens, it will always be smaller, and it will always be upright and virtual.